This lesson continues some more work on circles and some different ways to look at these equations so that we can kind of recognize that there's circle equations look different. Of course, this is the basic equation for a circle. The standard form of a circle looks like this. And we know that that all works fine and dandy and beautifully. What I want to look at is if I have the center and then know a point that it contains, how I can put something in this form right here, okay? And actually I'm going to put it in a couple of different forms, okay? So the problem here is that I need to figure out the radius. So if you were to sort of think about this and think about a graph, if I were to plot the point -4, 1, that would look right there. And that's the center of the circle, and I know that it contains the point 5, -4. So I know that the circle contains this point. And what that means is that the circle, if you can picture it, would go like that. Okay? That means that this distance right here, of course, is the radius. And I need to know that distance. So basically, I need to find the distance between -4, 1 and 5, -4. And that will tell me my radius. So my radius then will be x2 minus x1 squared plus y2 minus y1 squared, and kind of figure that out. So of course -4 minus 9 or minus 5 is -9 squared is 81. -4 minus a -1 is 3 squared. No, sorry. -1 minus -4 is 5 squared is 25. So you have the square root of 106. And the square root of 106 is your radius, okay? So then when you put this information into this formula kind of right here, and you plot that in, your center, of course, h is the x value of your center. So your center, the x value of your center is at -4, so you'll have x minus -4, which of course becomes x plus 4. And then y minus your y value of your center, which of course is 1. And then your radius is the square root of 106. But when you square 106, square the square root of 106. So when I square the square root of 106, those two will just undo each other. And of course, you will just have 106 right here. So this is one way. This is sort of the standard form of that circle. But I also want you to recognize that we can not really simplify that, but sort of FOIL these things out and change the format of this. So if I take x plus 4 squared, of course that really means that I'm taking x plus 4 times x plus 4. And when I FOIL that out, I will get x squared plus 8x plus 16. Okay? Then when I do y minus 1, again, it really means I'm doing y minus 1 times y minus 1. When I FOIL that out, I will have y squared minus 2y plus 1 equals 106. And then of course, if you want to get this so that it's in the other form, you would want to combine your like terms. So of course I will subtract 106 over. Okay, and then I will have x squared plus 8x plus y squared minus 2y, and then I'm going to combine this 16 and this 1 and this -106. So when I combine 16 and 1 and -106, I get -89 equals 0. And these two equations are the same equation for the circle that has center -4, 1 and contains the point 5, -4. They're both the same kind of equation. Okay? All right, now I'm asking you to graph this. And you can use your graphing calculators to help you. You know that f of x is like y. You know that. But what that really wants you to do is it really wants you to plug some numbers in. Okay? So I'm going to just give you just a few numbers to plug in. Okay? I'm going to make a handy-dandy little table right here. What this really means is let's find f at 4. So when your x value is 4, then you'll type in 9 minus 4 squared. Well, if my x value is 4, 9 minus 4 squared would be 9 minus 16. which of course that means you have the square root of negative 7, and you can't take the square root of a negative. So this is actually undefined. Okay? I'll give you kind of another number to plug in. When x is negative 3, then you put negative 3 in here. Okay? And f of negative 3 would be 9 minus negative 3 squared. Okay? Well, negative 3 squared is 9, so I have the square root of 9 minus 9, and the square root of 9 minus 9 is 0. Okay? Now, we know that you can use your tables to help you figure this out. So if you kind of look at your tables, first of all, I need to put this function into my y equals. So I'm going to go up to my y equals, and I will put in the square root of 9 minus x squared. Okay, the square root of 9 minus x squared. Okay, then I'm going to go to my table up here. Notice it's undefined for x values that are 4, 5, 6, 7, 8. It does give me decimal values for some of these other numbers in between. Notice that it is pretty symmetric. So I can plot the point 0, 3, 1, 2.83, 2, 2.24, 3, 0. I can plot these points right here. Okay? Again, undefined for x values that are negative 4 and smaller. Okay? Then if we go look at the graph, oops, what I want you to be able to picture is that this is really half of a circle, okay? It's half of a circle, and I will explain why that works in a minute, but it is half of a circle. Okay, so I'm going to go back to my smartboard lesson here. And if we were to plot some of those points from our table, of course we could plot the point 0, 3. We could plot the point negative 3, 0. Positive 3, 0. And you can get decimal values for the other ones if you want, but this does give you half of a circle. Now, it only gives you the upper half of a circle because it's this function is only the positive root. I wonder if you could figure out that if I gave you this equation, okay, if that was the equation I gave you, I'm going to circle this in red. If that was the equation I gave you, I hope that you could use your calculator in your tables and whatever and figure out that this is what your graph would look like. Okay? When you get these are really half of circles. And I want to show you why that is. Okay? You know that I could have a circle whose center, like if I look at this circle right here, and I know that it doesn't have, it's not giving me the other half, but if I were to complete the circle, of course it would look like this. Okay? And I know that that's not down there, but if I were to complete it, that's what it would look like. I want you to notice that the center is 0, 0, and that the radius is 3. Okay? So if you were to think of this in standard form, like this, this is what it would look like. Your h is 0, your k is 0, your radius is 3. So you would have x squared plus y squared equals 9. Okay? If I solve this equation for y squared now, I have y squared equals 9 minus x squared. And of course, then I can take the square root of both sides. And when I take the square root of both sides, this is what I have. And so you can see how you get half of a circle. Technically, the answer to this would be positive and negative to get the whole entire circle. But when it drops one of the roots like that, then you know you only have, in this case, the upper half. Okay, so that's what that looks like. All right, this is similar, you guys, but I kind of want you to think about this. This one you cannot use your calculator to help you because you don't have a way to input y values. So you have to think about the last one we did and see if this helps. I hope you can picture that what this is it's really the circle x squared plus y squared equals 16. In this case, though, I'm solving for x. Okay? So now I will have x squared equals 16 minus y squared. Square root both sides. And x will be, of course, and this time I'm using the negative root. I'm not using both, but 16 minus y squared. Okay, now, when it was the other way around, and if it was f of x, you know you had the top half of a circle or the bottom half of the circle, depending on whether you had the positive root or the negative root. If it goes this way, I hope you can figure out that you'll either have the right half of the circle or the left half of the circle. Okay? In this case, it's centered at 0, 0, and the radius is 4. Okay, so the whole circle would look something like this. Okay, the whole circle would look something like this. But you don't have the whole circle. You only have the negative part of it. And basically what you're going to have this time is you're going to have the left half. Okay, so this actually should be your answer to this problem, is the left half. Okay, if you wanted to use your tables to sort of figure this out, you're going to have to do them by hand because you don't have a way to input your y values, okay? So if you use your table, in this case what you're going to have to do is you're going to have to plug in numbers for y. So let's say I plug in 5 for y. Then I would have f of 5, and I would have the square root of 16 minus 5 squared, which is 16 minus 25. That gives you a negative number. You can't do that, okay? So this is undefined. If you put in 4 for y, okay, then if I put in 4 for y, I will have negative of the square root of 16 minus 4 squared. Well, 16 minus 4 squared is 16 minus 16, which is 0. And I would get 0 for my x value. Okay? If I put in 2 for y, let's say, okay, then I would have negative the square root of 16 minus 2 squared, which is 4. Of course, that would give me negative square root of 12. And you can get a decimal for that. It's 2 point something. I can't remember, but it would be negative 2 point something. Okay? So when I put in 2 for y, my x value comes out to be negative 2 point something something something. You can figure out what the square root of 12 is. Okay? Same thing is going to happen when I put in negative 2 for y. I will get the same answer. So if you want to use your tables to help you picture that, that is a way that you can do that. Okay? This is the negative root again, so you have the left half of the circle. If it's a positive root, you would have the right half of a circle if it's y underneath the radical. All right, then just one more here. You have a pool at a park that is circular, and you want to find the equation of the circle that is the boundary of the pool area. The area of the pool is 700 square feet, and 0, 0 represents the center of the pool. All right, so if you can kind of picture this, basically you have a pool right here that is centered at 0, 0, and you have a circle here, and the area of the circle, and you know that to find the area of the circle you do pi r squared. Okay? So the reason that's going to be helpful is it will help us find our radius. So I know that 700 is pi r squared. Okay? If I divide by pi then, I know that r squared is 700 divided by pi. Okay? So then when I go to this equation, this standard form for a circle, I can kind of plug in what I know. I know that my h is 0. I know that my k is 0. So I know I'll have x squared plus y squared. And then I know that my radius squared, I already know my radius squared, is 700 over pi. So that's what that equation will look like. Okay? And we will see you next time.